Hi friends, in this video I'm going to explain you various objective type questions on heating effect of electric current, power and energy.
Let's begin with the first question. Unit of electric power may be expressed as first option volt ampere, second option kilowatt hour, third option watt second, and fourth option joule second. See, we know the expression for power P is equal to V into I. The unit for potential difference is V and for current is ampere. So, the unit for power can be volt ampere. Option A is the correct answer. Whereas option B and C is the unit for energy. Okay, so this is not the option D is not the correct answer. So the correct answer would be volt ampere, option A. Second question. What is the commercial unit of electrical energy? Represent it in terms of joules. See, the commercial unit of energy is kilowatt hour. And this 1 kilowatt hour, 1 kilowatt is can be written as 1000 watt into 1 hour is equal to 3600 seconds. So when we multiply this, we get 36 lakh joule. But among the options, 36 we find in option A, and that too it is 3.6 into 10 to the power 6. That's right, because when we shift the decimal, we get 3.6 into 10 to the power 6 joule. Option A is the correct answer. Third question. Assertion. A fuse wire is always connected in parallel with main line. And reason, if a current larger than the specified value flows through the wire or the circuit, the fuse wire melts. See, we know that the fuse wire will be connected in series with the phase line, and the loads will be connected parallelly like this. This is the fuse wire. It is connected in series but not in parallel. So, assertion is wrong. And when this fuse wire will melt? Only when the current is greater than the rated current. Okay, so reason is correct. Assertion is false and reason is correct. So it must be option D. Assertion is false but reason is true. Option D is the correct answer. Next question. What is the commercial unit of energy? Just now we have seen the commercial unit of energy is kilowatt hour, which is the larger unit of energy. Option A is the correct answer. Joule is SI unit of energy. Watt hour is smaller unit of energy. Okay, it's a unit of energy, and erg is also unit of energy, but the commercial unit of energy is only kilowatt hour. The correct answer would be option A. What is electric power? Rate at which energy is consumed is called electric power. Option B. Rate at which energy per hour is consumed is called electric power. Rate at which energy keeps flowing is called electric power. None of the above. See, the definition for electric power, it is rate at which electric energy is consumed. D by dt represents the rate at which E is energy, the rate at which energy is consumed. So option A is the correct answer. Sixth question, state SI unit of electric power. See, the SI unit of electric power is watt. Okay. Option C is the correct answer. Seventh question, write the relationship between resistance of filament of bulb, its power, and constant voltage. See, we know power is equal to V into I. It is product of voltage and current. And instead of I, if I substitute I is equal to V by R according to Ohm's law, we get V into V by R, which means V square by R. Okay. So from this we can write the power expression as V square is equal to P into R. Okay. Option A is the correct answer. Eighth question. Joule's law of heating states that the heat produced in a conductor is directly proportional to square of the current, option A, resistance, option B, time, option C, all of the above, option D. See, we know according to Joule's law of heating, H is equal to I square RT. Okay, the amount of heat which has been dissipated in a circuit is given by H is equal to I square RT. That means H is directly proportional to square of the current, correct? Resistance, correct? Time, correct. So all of the above would be the correct answer. Option D. The heating effect of electric current is utilized in. See, we know when we pass current through a wire, especially nichrome, it provides a lot of heat. It's an alloy used in electric iron, yes, and other heating elements. So heating effect of electric current is utilized in electric iron, room heater, water heater. So therefore it must be all of the above. All of the above. D, option D is the correct answer. Dash energy is the total work done in maintaining an electric current in an electric circuit for a given time. See, dash is a total work done in maintaining an electric current in electric circuit for a given time. That means it is not heat energy, it is not thermal energy, it is not none of the above. It must be option A, electric energy. Okay, electric energy is the one which maintains electric current for a given time. Okay, eleventh question, fuse has dash melting point. See, usually the fuse wire will be having low melting point. Why? Because if the current is above the rated value, then it has to melt. Okay, if it is having high melting point, then it cannot protect the equipment from damage. So option A is the correct answer. Fuse is always connected in series with live wire. In the previous question we have seen, it is connected in series. Option B. 1 kilowatt is equal to, see, we know 1 kilowatt is equal to 1000 watt. Option E is the correct answer. The dash rating of an appliance is electric energy consumed per second by appliance when connected across the marked voltage of the mains. See, energy per second, energy per time, what do we call? It's power. So option A is the correct answer. Efficiency of an electrical device is the ratio of dash power to dash power. See, efficiency is defined as output power to input power. So option A is the correct answer. Calculate the total cost of running the following electrical devices in the month of September if the rate of 1 unit of electricity is 6 rupees, electric heater of 1000 watt for 5 hours and electric refrigerator of 400 watt for 10 hours daily. So, what all the things we are given with? We need to find the cost. So, the formula for cost is energy into rate. So, rate is given 6 rupees per unit. We need to find energy. How to find energy? Energy is equal to power into time. See, here we have two power, 100 watt and 1000 watt. Okay, operated for different times. Okay, so electric heater operated for 5 hours and refrigerator operated for 10 hours. So therefore 1000 into 5 will give you energy of electric heater. So we can write the formula for energy as P1 into T1, P2 into T2. So here 1000 into 5 plus 400 into 10. Okay, so it must be 9000 watt hour. Okay, it must be 9000 watt hour. So we have to convert to kilowatt hour. It is 9 kilowatt hour. This is per day. Suppose if you have to calculate for September month. So how many days we have for the September? It's 30 days. So we need to multiply this by 30. Okay. So when we multiply by 30, we get 9 into 30 kilowatt hour. That will be the energy per month, September month. So 270. And this is the energy we need to multiply with the cost. Okay. So energy into, sorry, we have to multiply with rate to get the cost. Cost is in rupees. So 270 into 6. Okay. So here we get 1620 rupees. It is option C. Option C is the correct answer. Why is tungsten used for filament of electric lamps? Give reason for your answer. See, tungsten should have a very high melting point because it has to glow at high temperature. So it should become red hot, and its resistivity should be high. It cannot have low melting point. If it is low melting point, it will burn. So therefore we can't get light. So option D will be the correct answer because it is both option A and B. So that must be, correct answer must be option D. A bulb is rated at 200 volt 40 watt. What is its resistance? See, voltage is given, power is given. How to find resistance? R is equal to V square by P. This is the relation. Okay, so 200 into 200 divided by 40. So if you cancel, you get 1000 ohm. Option C is the correct answer. A bulb is rated 200 volt 40 watts. 5 such bulbs are lighted for 5 hours. Find their cost if the rate is 5.10 per kilowatt hour. So here 40 watts, 5 such bulbs we need to take. So 40 into 5. So 200 watt is used for 5 hours. So we need to multiply by time. So we get the energy. So energy is equal to power into time. Okay. And when we multiply this, we get the energy. To get the cost, we need to multiply the energy with rate. So this is equal to, so we get 200 into 5, which is 1000 into 5.10. So this 1000, it's going to be in watt hour, but we need it in kilowatt hour. So it is 1 kilowatt hour. 1 kilowatt hour into 5.10 per kilowatt hour. So the answer is 5.10. Option A is the correct answer. That means 1 kilowatt hour into 5.10 per kilowatt hour. So we get 5.10. That will be the cost. An electric iron has a rating of 750 watt, 220 volt. What is the current passing through it? Having given the power and voltage, we need to find the current. So current is equal to P by V. The relationship between power and the voltage is P is equal to V into I. Okay, so from this we can get the expression for current. So this is equal to 750 divided by 220. Okay, so when we cancel and we get the answer 3.4. Option C is the correct answer. A geyser is rated 1500 watt, 250 volt. It is connected to 250 volt means what amount of energy consumed in 50 hours? We have power, we have voltage and time. Okay, so we know energy is equal to power into time. So power is 1500 into time is 50. So it must be 75,000 watt hour, but if we convert it to kilowatt hour, we get 75 kilowatt hour. So option B is the correct answer. In the above image, a 240 volt AC mains circuit is connected to number of appliances and switched on. What is the power supplied to the circuit? Voltage is given and it is connected to number of appliances and switched on. What is the power supplied? So we need to add and find the total power. So let us have it in watts or kilowatts. So if we have it in kilowatts, 1.2 first one, second one it's going to be 0.2 kilowatt, 60 plus 60 120, so 120 means 0.12, so we get 1.52 kilowatt. Option D is the correct answer. In the above image, 240 volt AC mains circuit is connected to a number of appliances and switched on. What is the current in the refrigerator? See, this is the refrigerator and the power is given and the voltage is given. So when power and voltage is given, how will you find the current? Current is equal to P by V. So here 200 divided by 240. If you cancel, you get 5 divided by 6. Okay, so when you find the fraction, the option is 0.83. 83 is the correct answer. The same question, we need to find out the resistance of the filament. How to find the resistance of the filament? So these are the two filaments available. We need to find the resistance of the filament. Any one filament we can take. So resistance is equal to V square by P. So here it is 240 into 240 is going to be V square, okay, into that's what, 240 into 240 divided by P. P is 60. So you can cancel this and find out. 960 is the correct answer. Option D is the correct answer. Out of two electric bulbs of 50 watt 220 volt and 100 watt 220 volt, which one will glow brighter when they are connected in parallel? You might have seen in your house that the 100 watts bulb will be glowing more because in our house parallelly the appliances or the equipments are being connected. So the one which is having more wattage will be glowing more in parallel circuit. So option B is the correct answer. A cable of resistance 12 ohm carries electric power from a generator producing 250 kilowatt at 10,000 volt. How much the current is there in the cable? Resistance is given, then power is known, then voltage is known. How to find current? See, we know V is equal to I into R. So we can find I. I is equal to V by R. So V is 10,000 volt divided by R is 12. Okay. In this case, they have mentioned the power also. So in another way we can find. See, we know P is equal to V into I. So from this we can find what is I. I is equal to P by V. So what is P? P is 250 kilowatt divided by voltage is 10,000. 3 zeros get cancelled and 4 zeros get cancelled. We get 25 amps. So we have to find the current in the cable, which is 25 amps. Option B is the correct answer. Two bulbs have the following rating: 40 watts at 220 volt and 40 watts at 110 volt. The filament of which bulb has high resistance? So here power is given, voltage is given. Okay, so how to find current? I is equal to P by V. So here P is 40 and V is 220. So if you cancel, you get 2 by 11. And then go for the second one. It is 40 divided by 110. It is 4 by 11. Okay. So the one which has got less current will be having higher resistance, isn't it? So therefore, the first one will be having less current, they have the higher resistance. So it must be first bulb. Next question. An electric motor takes 5 amps from a 220 volt line. What is the power of the motor? So here current is given, voltage is given, we can find the power. Power is equal to V into I. Cos phi it's going to be 1. Fine. So this is equal to 220 into 5. So we get 1.1 kilowatt. Option C is the correct answer. Next question. An electric motor takes 5 amps from 220 volt line. How much energy is consumed in 2 hours? So we need to find energy. Energy is equal to V into I into T, because here current, voltage and time is being specified. So this is equal to 220 into 5 into 2. So we will be getting 2.2. Okay, 2.2 kilowatt hour. So option A is the correct answer. Which of the following terms does not represent electrical power? So we know the power expression P is equal to P into I. When I substitute P is equal to I into R, I get I square R. When I substitute I is equal to V by R, I get V square by R. Okay, the expression for the power can be written this way. So here, which you would think that is the correct answer? Which is not, which does not represent the electric power is going to be IR square. Okay, option B is the answer. How much power is used in 2 ohm resistor when 4 volt battery is connected parallel with 2 ohm and 2 ohm 12 ohm resistor? See, we have 2 ohm and 12 ohm resistors. Okay, they are connected in parallel with 4 volt battery. Okay, 2 ohm and 12 ohm. So now we need to find how much power is used in 2 ohm resistor. So we need to find the power here. So how to find the power? I square R or V square by R. So voltage is the same. So we can find the power here, that is P2. So P2 is equal to V square divided by R2. Okay, so we get 4 square is 16 divided by 2, which is 8 watt. 8 watt is the correct answer. Option B. How much power is used in 2 ohm resistor when a 6 volt battery is connected in series with 1 ohm and 2 ohm? So we have here 1 ohm and 2 ohm resistors. It is connected to 6 volt battery. Okay, and we need to find what is the power across this 2 ohm resistor. So we need to find the current. So current I is equal to V by R, total current. Okay, so 6 divided by 3, that means you need to add the 2 resistance. Total resistance, we need to always remember that in order to find the current in the series circuit, consider both the resistance. That means consider the total resistance. So it's going to be 6 divided by 3, which is 2 amps. And what is the formula for power? Power is equal to I square R, right? So here 2 square into R. Here we need to find in 2 ohm resistor. So therefore we should take R2 as 2. So 2 square into 2. So 4 2s are 8. 8 watt is the correct answer. 2 square into 2. So answer is option D, 8 watt. Which uses more energy, 250 watt TV set in 1 hour or 1200 watt toaster in 10 minutes? See, the energy for the TV set is taken as E1 and the energy for the toaster is taken E2. Power into time will be the expression. So therefore 250 into 1 hour. Okay, it's going to be 0.25 kilowatt. But when we go for toaster, it is 1200 into 10, which is going to be 12 kilowatt. Oh, sorry, it is given in minutes. We have to convert it into hour. So how do you convert minutes to hour? Or else this is in minutes, we need to convert it into seconds and see. So minutes can be converted to seconds by multiplying with 60. Okay, so you can have it in Joule. So here 1 hour means 3600 seconds. So which is more? TV set is going to consume more energy. Option A is the correct answer. Next question. Assertion. Fuse is placed in series with the device. Reason. Fuse consists of a piece of wire made up of metal or alloy of appropriate melting point. Yes, fuse is placed in series. We know that. That's right. Reason is fuse consisting of a piece of wire made of metal or alloy, correct, of appropriate melting point. Fine, that's also right. So both A and R are true and is the correct explanation. And here the fuse consists of a piece of wire made up of metal or an alloy of appropriate melting point. It must have low melting point, not appropriate, because it has to melt above the rated current. So option A we cannot say, because it is not correct explanation of the assertion, because it is connected in series. The correct explanation is not given. So option B is the correct answer. Both A and R are true. Okay, it's having the appropriate melting point, that means a low melting point. But why it should be connected in series? It can be connected in parallel, no? So that must be the reason. So the reason is not appropriate. So option B is the correct answer. Okay, option B is the correct answer. Next question. Tungsten metal is used for making filaments of incandescent lamps. Reason is melting point of tungsten is very low. Now assertion is right, it is used for making filaments of incandescent lamp, but the melting point of the tungsten cannot be low, it must be high. So the reason is false, assertion is true. Then option A is C is right. A is true but R is false. Option C is the correct answer. The SI unit of energy is, it's Joule. Option A. How much energy does a 100-watt electric bulb transfer in 1 minute? So the formula for energy is power into time. So here power is 100 watt and time is 1 minute. So 1 minute is equal to 60 seconds. So we need to have it in joule. So therefore it is 6000 joule. Option D is the correct
I
answer.
have discussed various objective type questions on heating effect of electric current, power and energy. If you like the video, kindly click the like button and subscribe my channel to get the notifications for the upcoming videos. Thank you.